So in this last part of the lecture, we are going to make a quick overview of the function of nephron and of the flow of urine. So here we have the title overview of information of the tubular fluid and its transformation from to urine and outflow in the body. So here we see the nephron overview. So what we discussed today is the glomerular filtration, where the plasma fluid moves from glomerular capillaries into the Bowman space and then into the tubular system of the nephron. We also discussed that this is a process that is governed by Starling law on capillary, which depends primarily on hydrostatic pressure and on the amount of proteins. And it's practically hydrostatic pressure difference between the capillary and Bowman space, and oncotic pressure again in the capillary and Bowman space. So these are the filtration forces, but the hydrostatic pressure can also be affected by vasoconstricting or vasodilating each of the afferent or efferent arterioles, and this can lead to increase or decrease of glomerular filtration. Now, these are processes that are actually commonly in effect, whether this is a question of effect of prostaglandin on glomerular filtration or a drug ibuprofen that blocks prostaglandin production, or the effect of angiotensin 2, which can be blocked during treatment of hypertension. So all this is mediated by the effect on smooth muscle of afferent or efferent arteriole, and common processes can influence the amount of blood that can induce the hydrostatic pressure and induce the glomerular filtration. So then we, as the fluid moves into the proximal convoluted tubule, we see here that we are resorbing solutes, right? And because this part is a water permeable area, the water follows these solutes, and so at the end we have the same osmotic pressure as in the blood. Then we have the descending part of Henle loop that is going in the environment with growing osmolarity within the interstitium. And because the wall is permeable for water, water is being drawn from the descending limb of Henle loop. So the highest osmolarity is here at the tip, and then the wall becomes impermeable for water. You see, there is no blue arrow here, so the water cannot move. And instead, we have there the big pumps like sodium, potassium to chloride pump that is moving the electrolytes from the inside, where it's high concentration, to outside and creating the osmolarity gradient of the interstitium. So now we have the actually hyposmolar fluid, because we still continue removing electrolytes. So this fluid here is hyposmolar, and then we can start removing also water, depending on how activated are the channels, aquaporin channels that react with antidiuretic hormone. So fluid water can still be getting out. And here we have also effect of solutes, which is the effect of aldosterone that can be removed or kept depending on what is the status of osmolarity and fluid volume in the body. So we talked here about filtration and about absorption of many electrolytes and water. And we did not talk in today's lecture about secretion. Now, if we summarize how the urine is formed and how it flows out of the body, it starts in the glomeruli, which are in the cortex, right? The filtrate of plasma is then moving into the tubular system, and it's modified in a way so that we don't lose much fluid. And then from proximal tubule, Henle lobe, and distal convoluted tubule to collecting ducts. And at the end of collecting ducts, we practically have a formed urine, and individual nephrons are heading towards the papilla, and in papilla, the fluid from papilla, the fluid continues into calyces and to renal pelvis, and from here to towards the bladder, which we see here. We see from kidneys departs the ureter, arrives to bladder, and we do have differences between female and male, not up to the bladder level, but only in the urethra. So in the urethra in women is short, and it's the outlet on its own for urinary system, while in men, the urethra forms outlet not only for urine, but also for ejaculate that arrives to urethra first through vas deferens, then with the seminal vesicles combination with the fluid, and prostate fluid becomes ejaculate duct, and the ejaculate duct is now emptying its content into urethra and out of the penis. All right, so that will be all for today, and I wish you all the best.